All right. So before we actually get started with our token contract, I think it's best if we take a step back and really understand what this whole ERC-20 thing is all about, right? I mean, because if you're new to Solidity, I'm pretty sure you guys have heard of this term like ERC-20. I think I've mentioned it a couple of times in our video too. And like it's one of those terms that keeps popping up everywhere. Like it's used everywhere. But the thing is, it's rarely properly explained, right? But if you have been paying attention, you might have figured out that ERC-20 has something to do with tokens, right? It has something to do with tokens. So the one thing that you have to understand about this token business is that it can be any kind of token, but the underlying fact is that all of it is just smart contracts. Like underneath every token that you have seen or heard or have tweeted about, it's just smart contracts, right? So like it's basically a piece of code that is deployed on the blockchain, and that code basically keep track of the balances. It defines how the token transfers work and even decides what rules govern the token's behavior. So it's all just code, it's all just smart contracts. So when you send a token, you're not actually moving coins around like in a game inventory. Okay, what's really happening is that the contract, like the smart contract that defines these tokens, it updates a number in its internal storage. Like it subtracts some amount of token from one address or some amount from one address and just adds it to the another, like adds it to the other address that where you are sending the token to. So it's all logic, right? There is no actual movement of tokens. So the thing is, in the earlier days of Ethereum, like I'm talking about 2015, 2016, when Ethereum was very, very new. So everybody was excited with the whole concept of programmable money, right? Every developer wanted to try this out or test it out. So what ended up happening was that everybody was building their own versions of these token contracts, right? Like everybody wanted to create a token in their own name or maybe in their pet's name, their business, for utility, whatever. So everybody started creating contracts that handle tokens, right? Now the problem here was that there was no single standard, right? Every developer wrote their token in their own way or in different ways. So for example, one contract might call its transfer function send, another might call it move tokens, and someone else might store balance under a different variable name. So it was basically a lot of chaos because everybody was writing these token contracts in their own way. Now the real problem started when platforms or exchanges or wallets or dApps tried to interact with these tokens, because they couldn't interact reliably with these tokens because there wasn't a shared standard between them. So if they have to interact with a new token, they might have to integrate new piece of code, because the token might be using different names for its different functionalities, because everybody was writing their own versions of the token contract, right? So it was generally chaos, like when it comes to the whole token scene. So that's when the Ethereum community came together and said, all right, let's just fix this mess, right? And what these guys did is they proposed a set of common rules or standards that every token contract should follow. So if you're writing a token contract, these guys proposed a standard saying that, okay, if you're writing a token contract, follow these standards, right? And that proposal for standard became ERC-20, right? So, I mean, ERC stands for Ethereum Request for Comments, and 20 is basically the proposal number. So what it did is it basically said that if you're creating a token, just follow the rules that is given in the standard. Now it's not like complex rules. Okay, what ERC-20 did is that it defined a simple but powerful interface. It basically said that if you're creating a token, make sure that your contract includes all these functions, right? Like you can see it, like you can go to the official Ethereum page about ERC-20, and it will show you all the methods and stuff. Like, you have name, symbol, total supply, balance of transfer, like you have a couple of events and everything. So ERC-20 standard basically said that if anybody is creating tokens, make sure that you include all these methods, right? So the advantage here is that this brought in a standard. So if somebody says that they are creating an ERC-20 token, the function that you can call to transfer a token, or the function that you can call to get the balance or the total supply, right? So this created a standard for defining tokens or creating token contracts, right? And if your token followed these rules, it could instantly work with any wallet, any exchange, or any dApp that basically supported ERC-20. So they don't need to add any custom codes or any kind of special integration. So that is why ERC-20 completely changed the game. Before ERC-20, every token contract was basically different because everybody was writing it in their own way. With ERC-20 standard, it turned the whole token contracts from isolated little programs into interoperable assets that could move freely across the entire Ethereum ecosystem. Now the thing is, if you know Solidity, you can basically write your own ERC-20 token contract from scratch, right? All you have to do is include all these functions, right? So you can directly do it. But the thing is, writing an ERC-20 token from scratch is kind of like trying to build a car, on your own, because it takes a lot of work, and it's risky, and it's time consuming, and you can easily mess it up. Like, a lot of things can go wrong. So that is where libraries like OpenZeppelin comes in. Okay, so OpenZeppelin is basically an open source library that contains a lot of battle tested smart contracts. Okay, and these contracts are audited, they are reviewed and used by thousands of projects across Web3, right? So what they do is, it contains secure implementations of standards like ERC-20. Like, you can just go to their documentation and you can see, like, under tokens, you can see, like, these are different token standards, and you can go to ERC-20. And the thing is, they have contracts that has already defined everything. So what you can do is, when you are writing an ERC-20 token contract, you don't have to write the entire function. All you have to do is, you just have to import the OpenZeppelin ERC-20 contract, and you can inherit it in your contract. And all you have to do is just provide all these things like the token name and symbol and initial supply and stuff. And all the other code, all the other functions and everything will basically be taken care of by the tried and tested OpenZeppelin library. So it's a very convenient way, meaning instead of writing 50 line of code for an ERC-20 token, you can do it in 5, right? And like I already mentioned, like, these are like tested contracts, so you don't have to worry about security, you don't have to worry about the code optimization or anything, right? These are like proper tested contracts that you can import onto your own uh, you know a contract and create an ERC-20 token with, right? So before we dive into the code, what you have to understand is that tokens are just contracts, and ERC-20 is basically a standard or a shared language that makes the contracts universal. Like, it is basically a set of rules that we have to follow while writing a contract that handles a token, right? And OpenZeppelin is a toolkit that makes building these tokens super simple and super safe. All right. Okay, so I guess that's the crash course. Now let's just go ahead and build our token contract. I mean, yeah, ERC-20 token contract.